Here we're going to look at a general set of strategies for answering questions you just don't know how to answer. Now, there could be obvious reasons why you don't know how to answer a question. As we said before, it was explained in class and you weren't there, or you weren't paying attention. Or that class was Thursday, the homework is due Monday, and you waited until Sunday night and can't remember what was in the class, because 3 days is a long time to try and retain something as abstract as brand new math without practicing. We also talked about how problems ramp up in difficulty very slowly. So if you answered question 1 and skipped to question 7, maybe if you did the questions in between, you would have been able to figure out what's necessary for question 7 by taking smaller steps along the way. So there are problems that you can solve by just not having them in the first place. But there are also questions that are just plain confusing and hard, and I want to try and claim that they don't exist. Remember that if a question is easy, you don't just say, "That's easy," and skip a few questions later. The "that's easy" question is just going to come back later as a smaller part of a larger complicated question. And later could be in 10 minutes or in 3 months. So doing all of them when they're easy will make things easier down the road. But if you were listening critically, at the end of the last video, I mentioned that when we make a question a little harder, the extra step involved almost always shows up at the front end. So the hardest part of most questions is the beginning part. So it's very common to start a question and say, "I don't know where to start." The secret weapon in math is usually formulas. That's the power of math. It takes one super smart person to come up with a formula, but after that, anyone can use it anytime they want. A good formula is smarter than you are, smarter than I am, smarter than most of us. So, and this would be a grade 8 example, if there's a question about, say, the volume of a cylinder, you are not getting to the end of that question without writing the formula for volume of a cylinder. So if you are staring at the question, not sure where to start, writing down the formula for volume of a cylinder, that's it. So if you are staring at the question, not sure where to start, write down the formula for volume of a cylinder. Now I can look at it and say, okay, it needs 2 numbers, the radius and the height. And if I can find those 2 numbers, I know what I have to do. But nearly every section has some variation of that, where there's a thing I can write in its general form, and if I can find numbers to plug in for the various letters, eventually I've filled in enough numbers to where I can start to make progress. Now, if you can't find a formula, look at the vocabulary, because words always have very specific meanings in math, and those meanings are supposed to remind you of particular things. So, for example, we never talk about vague things like the size of a circle. Circles have a radius, a diameter, a circumference, and an area, and each one of those means something particular. So the radius means the line that goes from the exact center to the edge, and that's half as long as the line that goes through the center but from one edge to the other edge. And if I think radius is that line in the circle, is that the one that goes all the way across, part way across? Does it go through the center? I won't be sure if I want that number or something else. Do I divide it by 2, multiply it by 2, pi times that squared? I don't know. But because radius has such an exact meaning, when it winds up in a sentence, it's not usually possible to do that thing you can do in English where you can read the whole paragraph and kind of get a vague sense of what that word means. So if you're not sure where to start on a question, look for a word in the question where you say to yourself, am I really sure exactly what that means? Or do I just kind of know what it means? Because looking up exactly what it means might give you a hint as to how it relates to the question and point you in the right direction. Now, when you've found a starting point, what's next? You can solve a problem, or at least get to a problem to a point where you can solve it without realizing it, because there are 2 situations where you are basically home free. One is if I just have a long string of numbers and I can just do BEDMAS. If that's all there is, great. It might take 45 seconds, but as far as my brain is concerned, I won that question. The other is if I have an equation, where there's one letter that I don't know. Because remember, you spent a lot of time in grade 7 and 8, and we'll spend more time in grade 9 learning how to solve that. Basically, if I can get that letter by itself, that's the answer. The other strategy is something called working backwards. If you don't know how to start, read the question and imagine what the answer would be. So it might be something like, what is the height of the Frisbee after 9 seconds? My answer will be, the height of the Frisbee is. That means one step before that will be h equals something. So I've answered enough math questions to know how that happens. There will be an equation or a formula. H will be in there somewhere, but every other variable will go away, either because someone will tell me the value for it or I will figure out the value for it. Then I will be able to find H by getting it by itself. Okay, is there an equation given? Can I make one? Was there one in that box at the end of the lesson? Okay, now if you're also listening critically at the end of the last video in this series, you'll notice I said there were A, B, and C part questions, but I didn't say anything about the C part. C part questions are legitimately hard and usually require you to come up with something which is beyond what you've been taught, but usually only by just a little bit. My opinion, and this is partially practical as well, is that if you get assigned one and find that it's tough, do not worry about it at all. Sure, I mean, sit there for 4 minutes to see if you can get somewhere with it, but if nothing comes to you and that question gets left blank, totally fine. Now, in the next class, you should, with guilt or embarrassment or anything like that, raise your hand and say, I couldn't get question 18. Could you go over it? Now, you might find it interesting and learn something, but C-part questions are hard by definition. You shouldn't feel at all bad for not getting them really ever. The good news is that on a test, there is probably 0 and at most 1 of those questions. So as long as you are putting in the time and doing all of the A and B part questions, then you are spending your time doing homework really wisely. And the thing to remember in math is we never expect you to invent something new. Lots of this stuff was worked out over multiple people over hundreds of years, most of whom were smarter than you, me, or anybody else watching this. If you look at the way math class is structured, it's here's a concept that you were able to understand, even if you couldn't come up with it yourself, and here's how to use it. Go use it. Now fiddle with it a little bit to see if you can use it on a collection of problems that are, similar, but have some variety. Okay, now that we've done that 5 times, here's a test with a mixture of questions. Can you pick out the right one for the job and use it? And we basically repeat that every other day for whole school years at a time. So the primary skill is not necessarily problem solving, it's recognizing patterns and memory. Where have I seen this before? What worked last time? Will it work again? And that all cycles back to part 1 of this series, where you get immediately better at that the more homework you do, which is why this whole playlist is centered around getting you to do more work faster and often with much less stress.